Okay, so it is Tuesday, December 1st, 2020. It's officially the holiday season. Got a little Christmas tree and a menorah because I want to include people. And I was raised with Christmas and Hanukkah because my mom's side of the family's Jewish. So there you go. I got both. And today we're doing section 5.3, conditional probability and independence. The beginning of section 5.3. We'll do conditional probability today. And we might get into some of independence on Thursday. All right. If you're taking notes, there will be some things you want to add to your notes today, so please have that ready and available. And as always, if you have questions, I encourage you to please let me know. Raise your hand, unmute your mic, and shout at me. Put it in the chat. Any of those options work. All right. Before we get into the new content, a couple of things from grading that I did over the last week. Also, in Canvas, that is your most current possible grade. Everything's been graded as best as I could up through last night. There's a couple of people who got emails because some of their work did not open up for me. I couldn't see it. And I requested some copies of their work via email. So if you did get an email from me or you haven't checked your email, please check your email. I may have requested some stuff from you so I could finish grading your assignments. There's a couple of things that stood out to me as some errors from table A is your new friend. Many of you guys got question 2 wrong. I'd say, like, of the people who submitted the assignment, I think 90% got question 2 wrong. And it's not because you did the wrong stuff, it's that you misinterpreted the value you needed to provide. And so many of you said that the answer, all right, so many of you guys said that it was, I think, 1.54%, 58. So you said it was 1.58%. That was the most common answer. That is the proportion. So let's say this is 2.15 here, negative 2.15 standard deviations from the mean. This would be the mean here. 1, negative 1, right? 2, negative 2 is here, negative 3, and 3. So negative 2.15 would be right here. The 1.58% is what is less than. That was the proportion that you found. That's the proportion that's given on table A. Table A always gives you the less than proportion. On table A, you found 0.0158. You convert it to percentage, you got 1.58%. Because we wanted greater than, we wanted to know the area to the right of negative 2.15. So the correct thing to have done would have been 1 minus 0.0158, which would have equaled 0.9842. Or 98.42%, or you can set approximately 88%, give or take. All right, because we wanted that greater than. So sometimes you need to be careful when interpreting the table A type questions or the Z-score type questions. Are you looking for the less than amount or the greater than amount? Less than is the amount given on table A. If you want greater than, you need to take that number and subtract it from 1. All right. Any questions on this problem? This is the most common error I saw of all of the work that I looked over this weekend and this last week. Okay. The other thing that I saw confusion with is with a more recent topic, probability models and basic rules, A or B versus A and B. all right? There's or and and. Or and in mathematics, in probability, in other branches of mathematics, have very specific uses and meanings. Or is inclusive. When you see or linking two things together, it could be two sets, two events. In this case, we're talking about events. When or links those things together, we're saying either of these things can happen and everything's good. Those all count, so to say. So like more formally, we have A or B in an or statement, or we've also called these unions, A union B, right? To satisfy the statement, one or both of the events needs to occur, right? Either one can happen or both can happen. That's fine. That satisfies an or statement. A and B in an and statement or intersection, to satisfy the statement, both of the events must occur. There's no choice. You can't have one or the other. You must have both things happening simultaneously in an and statement. Okay? So you have to understand the difference between the two when you see them. Right? And in these things, we have our new notation for and or. We saw before break. Right? We can say A union B. We have A intersection B. And it's easy because this looks like a U, union, and this looks like an A almost, just missing the little cross, for and, for intersection. Okay, and that's how you can kind of remember them. All right. Any questions about the difference between or and and? We're talking about probability and events. All right. Please, if you have a question, you gotta let me know, guys, because it's probability builds on these basic things with and or, and it's gonna get more complicated over the next, week and a half. All right. Does anyone need a moment to write anything down from what I've gone over for their notes? All right. So what is conditional probability? I'm so glad you asked. Conditional probability piggybacks off the concept of conditional distributions that we've previously seen with categorical data. All right. Again, I mentioned this earlier. We've already talked about conditional distributions. All right. Now we're doing conditional probability. It uses the same kind of ideas and logic. Conditional probability is finding the probability of one event, right, under the condition that some other event is already known to have occurred. So I know that one thing's already happened. Now I need to find the probability this other thing has also occurred, right? This conditional event is often referred to as the given, right? Given is a thing that shows up in mathematics, it shows up here in probability, it shows up in a lot of other mathematics, especially as you move forward in the college mathematics and things. You'll see this given, blah, 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 blah. That means you can say that that is true. We know that this thing has happened. We know that this is correct when something is given, right? So, for example, say we're trying to find the probability that a student is female given that the student is taking AP Stats. So we have that statement, given that. This is a very common way to say, the given state. Right? The conditional event, right? The given event is that the student is taking AP Stats. The other event that we are trying to find the probability for is the student being female. I don't have the data for this. We're not going to actually solve this at the moment. I'm just trying to help you guys identify when you're given a statement, which thing's conditional and which thing I'm finding probability of. Because the conditional event helps us narrow down the numbers and the counts of things that we use. Right? So knowing what the conditional event is, or the given event, is going to help us correctly identify the conditional probability. All right. So I'm setting up for an example we're going to look at here. In a previous class, before break, we looked at an example about students having pierced ears in a large college statistics class where they collected data about gender and whether or not students in the class had pierced ears. In that study, right, there's 178 students in the class, and we have the data given right here. Right, this is a two-way table. We have gender and pierced ears as the two ways. In our previous example, we used two events. We had event A, which is student was male, and event B was the student has pierced ears. And we calculated these results. The probability that the student was male is 90 out of 178, right, because we have 90 males out of 178. Probability that they have pierced ears, right, 103 out of 178. Probability that they're male and have pierced ears, right? We only have 19 males who fit both conditions. That's an and statement. So they have to be male and have pierced ears to be counted. And then we have male or pierced ears. So we count anyone who's male and anyone who's got pierced ears because we're in an or statement. All right. And so, and again, remember in this one, we double counted these 19. So we added 90 plus 103 minus 19 to account for the double counting. And we ended up with 174 over 178. So these are all the previous results from the first time we looked at this example. Does anyone need any clarification on how these results were found? Now, staying with this example, and I'm leaving the previous results on the screen here, let's consider two new questions. Right. Question number one, if we know that a randomly selected student has pierced ears, what is the probability that the student is male? So what is the conditional event in question one here? We have two events here. Has pierced ears, student is male, right? So it's event A and B. In the chat, quickly just type A or B. Which one is the conditional event? You're going to get the question in the chat that I want you to answer in the chat as well. All right, we have one for B and one for A. Another vote for B. A, B, B, B. So we got two A's, B's, B's, another A. Right, another A. So again, we're looking for what is the conditional event? What is the given event? The one that we know has occurred. A little bit split here. All right. Can someone who voted for event A tell me why you think it's event A? That is the given event or the conditional event. One guy why do you think it's event A? Or someone who thinks it's event B, tell me why you think it's event B.
Can you hear me?
Yes, I can.
Okay, I think that it's event B because it's the given event, which is the one we know, and it says that we know that a randomly selected student has pierced ears.
Mm-hmm. Yes, thank you, Lizette.
Yeah.
So yeah, in the way that it's worded, so in this question setup, we didn't say given that. Instead, they said we know. If we know that the randomly selected student has pierced ears, so we already know that condition B is met. The student has pierced ears. What is the probability that the student is male? So we need to find the probability the student is male, right? We're trying to find the probability. So we can write this. What color should I use? So we're finding probability that the student is male given that the student has pierced ears. Now, it's not entirely necessary to write out the entire statement like that within the parentheses. I'm just doing it for clarification. So the use of knowing what the conditional statement is it allows me to narrow down my focus, right? Because I know that the student has to have pierced ears, that means I only need to look at the condition that students have pierced ears. I only need to look at the yes row, right? And then there's 19 males possible, right? So that means we have 19 out of 103 as the probability. So identifying the condition allows me to narrow down where I look in my two-way table. That's why I need to identify which one's conditional, which one's given, and which one am I identifying the probability for. All right. So now if we look at question 2, green, what's the given information for question 2? Again, we have the same two events. Student is male, event A, and student has pierced ears. That would be event B. So in this case, which is the given event? A or B? Yes, Jocelyn. Given, yes. Stephanie, yes. A. Given the student is male, right? And again, we know a randomly selected student is male. So now we can narrow down what we're looking at again, right? We're only going to need to look at the condition that the student was male. We look at that column of data, right? And in this column, again, there's 19 students with pierced ears. So the probability that we get event B given event A, right, so now I'm using a little bit more notation so I don't have to write as much. Right? We get the probability of 19 over 90. So again, the condition, just like when we're looking at conditional distributions, right? The condition tells me where to look, right? So I don't have to look at all the data. I can just look at this column or this row. Right? What questions do you have, or what can I clarify? Does anyone need a moment to write anything down for their notes? Please raise your hand. All right. So then this leads us to definition. So this is the textbook definition for conditional probability. The probability that one event happens given that another event is already known to have happened is called a conditional probability. So as we know that event A has happened, then the probability that event B happens given that A has happened is denoted by P, B, given A. So this bar, this straight up and down bar here, essentially takes the place of writing given that, right? So you read this as P, what's the probability of B given that A? Or you say B given A. So the second event written is the one that's given in this notation. All right, the order in which you list them in this notation matters. Okay. If you need a moment to write this down, can you please raise your hand? All right. So then here's another look at the math, right, behind the example we just did for the two different problems. We're just looking at how this is calculated. So our first problem, right, we were given that the student had pierced ears. We want to know what's the probability that that student is male, right? So we looked at the number of students who are male and have pierced ears, right? That's what we saw on the table, right? This number 19, male and pierced ears. And looked at the number of students with pierced ears total, 103. That gives us the probability, right? We can also calculate this if we use the actual probabilities we found previously, Right? The probability that the student is male and has pierced ears is 19 out of 178. Probability that the student has pierced ears is 103 out of 178. The 178th, when you have fractions dividing by fractions, right? If you have the same denominator, they cancel essentially, and you get with just the numerator divided by the other numerator, 19 out of 103, which is exactly what we found. The reason this is shown is because sometimes all you have is the probabilities and you don't necessarily have the two-way table. You might just be given the percentages, right? So you need to be able to interpret the percentage and use the percentages in the right places, or the fractions you're given in the right places, because you won't have the two-way table, right? Those things happen. So we need to understand a little bit about the math behind it, just in case we don't have all the resources, right? So in symbols, the probability that event A happens given event B is equal to the probability of A and B, or A intersection B, divided by the probability of B, right? And this gives us a general formula for computing a conditional probability. Before we go to that page, no worries, Christian. Does anyone need a moment on this page, or do you have any questions about this page of lots of numbers and fractions? So we get two parts to this rules, or these rules. Find the conditional probability P of A given B. We use the formula. Probability of A given B equals probability of A and B divided by probability of B. Right? Notice the given event is what ends up in the denominator spot. Okay. If we flip it, right, to find the conditional probability of B given A, we use the formula. Probability of B given A equals probability of B and A, which probability of A and B should be the same as probability of B and A. Then divided by probability of A. Again, the denominator here is the probability of the given event. I would definitely suggest these ideas get into your notes if you're taking notes. Does anyone need a moment to write these down? Please raise your hand. Right. So let's look at one last example here. All right, so we have this setup here. We want to find, we're using a Venn diagram here. So this kind of like yellow part is event A. Someone reads USA Today. The green middle part is the proportion of people that read both papers, New York Times and USA Today. Blue part is New York Times. That means it's 0.4, or they don't read either. Right, the rest of our population. What is the probability that a randomly selected resident who reads USA Today also reads the New York Times? Right. So probability of randomly selected resident who reads USA Today. Right. This is our given, which is event A also reads the New York Times. Right. And this is going to be event B. That's what we want the probability of. Now I don't have a two-way table here, so I have to use the proportions. We want to use the new rule. All right. We need to find probability of B given A. We know that that is probability of B and A divided by the probability of A. Now, this is, I'm kind of demonstrating how I would solve the problem. This is how I would do it. I'm actually writing out the notation again because it helps me not make mistakes. Right? And this is what I usually do when I do math. I do kind of extra steps just to confirm that I'm doing the proper steps. If you don't need to do that, it's fine. This is what I do. So the probability of B and A, right, that's our intersection here. Right, 0.05. Right? Probability of A, right, reads USA Today, right, is actually, wait, yeah, yeah. So the probability that someone reads USA Today is actually 0.4, right? This 0.05 is part of this whole circle that represents reads USA Today, right? So that's included. So we actually have 0.4. And do you guys see that? We're not excluding the 0.5, right? This yellow part includes, the yellow part is people who only read USA Today, right? The whole circle is everyone who reads USA Today. We're considering everyone who reads USA Today. So we have to add in that 0.05, sorry, right? And then this is where we grab our calculator. Should be 0.05 divided by 0.4. So we get 0.125 or 12.5%. Okay. Any questions on this example? Alrighty. Does anyone need a moment to write anything down from this example?
I actually had a question, or just like
Yeah.
to clarify what you did. So for probability B in parentheses B and A, so you added the 0.35 and 0.05, right?
So here, so what we have is the probability of A, right, of event A is 0.4. Because the probability that someone reads USA Today includes the intersection, that 0.05. It's the whole circle here. Right? If we're looking at probability of B, that would be 0.25, because it includes the 0.20 plus the intersection. Right? It includes the people who read both. When we're looking at just probability of A or probability of B. Right? The intersection itself can only count the people who read both. So it's just the 0.05, which is probability of A and B. The reason they have this broken out the way that it is in the Venn diagram is so that when these numbers are added up, it adds up to 1 or 100%. Oh, get off my computer. But when we are looking at the individual probabilities, like of event A and event B, we have to add back in that 0.05. Does that answer your question or clarify?
Yeah. Thank you.
Welcome. It's unique to a Venn diagram representation. So, yeah, that's kind of why I picked the example, because you'll see things like this, and I don't want you to be like thrown off by them. All right. Any other questions or clarification? So then, I'm gonna look at the discussion board. All right, so this is our discussion board problem. Right? We have students at the University of New Harmony. They received 10,000 course grades last semester. The two-way table below breaks down these grades by which school of the university taught the course. The schools are liberal arts, engineering and physical sciences, and health and human services. All right? So we have 3 categories for each way of the table, right? We have a two-way table. There's 3 things for the rows, 3 things for the columns. All right? College grades tend to be lower in engineering and physical sciences. They're calling that EPS, than in liberal arts and social sciences, which include health and human services. Choose a University of New Harmony course grade at random. We have 2 events to consider. E is the grade comes from an EPS course, and L, the grade is lower than a B. Right, so essentially, think of like all of the grades in a hat. We're going to select a grade at random, and it'll tell us if it's an A, B, or below a B, and what school it came from. All right, so a bunch of pieces of paper. There's 10,000 pieces of paper. It tells us all this information. All right, and we have the events. E, grade comes from EPS, and L, grade is lower than a B. So for like question 1, find the probability that the grade is lower than a B. Okay. So we have all these grades below B. Right? So what's the chances that you select one of the grades below a B out of the 10,000? I think that's what we're looking at. And then we have the probability of E given L, and then L given E. So we're doing both parts. All right. So again, the given information is the second item given here, the second item listed, or second event listed in the probability question. So you're looking at the category of grade is lower than a B for P of E given L. And then you're looking at the category of E for the course comes from EPS, the second one. All right. Is there anything else I can clarify about the questions?